In this lesson, we're going to look at the difference between a relation and a function in math. So in math, a relationship occurs when two quantities are connected in some way. For example, distance traveled versus time on a car trip. A relation is a mathematical representation of a relationship. And we could do that with an equation, a graph, table of values. These are all ways that we've already know for representing relations. So for example, the objects below are three different ways of representing the same relationship. What we have is an equation, we have the graph here, and we've got the table here, right? Three different ways of representing the exact same relationship. Here's a few other ways that we have of representing relations. You can have a set of ordered pairs. And you recognize this, or these two brackets here, they tell us set notation. So these squiggly brackets in particular mean that we're dealing with a set. Or we could have an arrow diagram. There's a way that you sometimes see relation shown. It's like an ordered pair. If I was to rewrite this using ordered pairs, it would just be the ordered pair -2, -1, and -1, 0. So the place where the arrow starts is our x-coordinate, and where it ends is the y-coordinate. Or we could have an input-output diagram, because when you think about it, x's are usually our independent values, so they are some number that we put into an equation, and then our output is our y value because it depends on what our x value is. And here in the middle is just our rule for what's going on, right? Oops, that was supposed to be a highlighter. Our rule for what's going on, in this case, we're going to add 1. So that would be the same as y equals x plus 1. Take an x value, add 1 to it, you've got your y value. So those are some different ways that we have of representing relations. So a relation. Again, just to recap before we go on, it's a mathematical representation of a relationship. So it requires two different quantities. Okay, so if that's what a relationship is, then what's a function? A function is a relation. So in order for something to be a function, it has to be a relation, first of all. It's a subset of relations is another way of saying it. So a function is a relation in which each element of the domain corresponds to exactly one element of the range. Each element of the domain corresponds to exactly one element of the range. That is, the x value cannot have two different y values. So it's pretty straightforward if you think about it this way. If you're checking to see if checking to see if a relation is a function, see if you can find any place, whether it's a graph or a table or an equation, where this one x value, whatever that number is, has two different y values. So maybe if x was 2 and you had a y value associated with it of 7 and another y value associated with -3, that would be not a function because you can only have one y value associated with each x value. So let's take a look at a couple of these examples just to show what this means. State whether each relation is a function or not. Let's start with B. That'll be the easiest one because when they're listed, it's pretty clear. So for 1, when x is 1, y is 1. I don't see any other x's listed here. I don't see 1 as an x anywhere else. I got 3 and I got 5. So since there's no replication of the x values, each x value, 1, 3, and 5, has got its own y value, and that would be a function. For this parabola here, and that's what this is, we're going to do a lot of work with parabolas and review them in time. But for now, this is what a parabola looks like. This is what y equals x squared looks like. And I can tell pretty easily on a graph if a relation is a function. If it's a function, then each x value is going to have its own y value, which I can see by none of the x values, or none of the points being on top of each other, right? Here's an example of 2 points that have the same x value. Maybe this would be the point 7, 5, and maybe this would be the point 7, 3, just to make up some numbers. They have the same x value, but different y values. That's not a function. So if I see 2 points lined up like that, it's not going to be a function. But clearly, as I look at this parabola, I have no 2 points where one is on top of the other, no matter what points I choose. So this one would also be a function. And this one might be a little harder to tell, but mostly what I'm looking for, again, is since we know we're looking for any place where one x value gives 2 different y values, what I'm looking for is 2 arrows coming out of the same x value. So I would read that as the point 215 along this line, and I'd read this as the point 230 along this line. And if I was to plot them, they'd be on top of each other. That 31 would be higher up, straight above the 215. That would be no function, not a function. So that's what we're looking for. We're looking for the same x value having 2 or more different y values. The vertical line test is an easy way to tell if something's a function. Since, as I pointed out, we can't have points on top of each other in a function, if we're looking at the graph, if I can draw a straight vertical line through 2 or more points on a graph, it wouldn't be a function. So if I was to take a ruler and just run it along, vertically along this graph, imagine this red line I just drew was actually a ruler and I could slide it. There's no place, if I slide that red line to the left or to the right, there's no place where it's going to touch that parabola graph at more than 1 point at a time. It's only ever going to touch it at 1 point at a time. So that's the vertical line test. So again, if I can't draw a vertical line through the graph in more than one place, then it's passing the vertical line test and it is a function. When I put a vertical line through it, it does touch it in more than one place, it's not a function. So that only works for graphs, of course, but it's an easy way to do it. State whether each graph shows a function. So, for example, I see a problem here. When x equals -1, we get the point -1, 3. But we also get the point -1, -3 in this piecemeal graph. So it's cutting through that same point twice. And as it says about this graphing note up above, if you have an open dot, it means that the endpoint is included. If you have a closed dot, it means the endpoint's not included. Well, in this case, we have closed dots in each case. Both of these dots are closed in, so we're including those endpoints. We're including the -1, 3 in each case. So not a function. For this one here, there's all kinds of places I can see where it fails the vertical line test. Because, again, imagine I could slide that red line back and forth. Pretty much everywhere on the graph, I'm cutting through 2 points at once. Here, where I just happen to pick a couple points, I have 2 and 1.4-ish, and 2 and -1.4-ish. So not a function again. And this one, well, if it's going to fail the vertical line test, it would be here on the y-axis, because there's nowhere else that it's clearly not going to fail anywhere else. But this is an open circle here on this one, which means that we're not including the endpoint of that line segment. So since we're not including the line segment, this one will be a function. It doesn't fail the vertical line test. There's no place on this graph where it cuts through 2 points at the same time vertically. So that's what a function is. That's how we check for it. Give this homework a try to reinforce the concept.